students, in previous unit we have seen crystal structure. Today in this video we are going to discuss about packing of particles in the crystal lattice. In crystal lattice, constituent particles, the constituent particles in a crystalline solid are closely packed the constituent particles in crystalline solid are treated as hard spheres. The closeness or compactness of the constituent particles maximize the interparticle attractions. The coordination number of any particle in the crystal lattice particle, or you can say sphere. The coordination number of any particle or sphere in the crystal lattice is nothing but the number of neighboring neighboring spheres that touch the given particle or sphere. The magnitude of coordination number is the measure of closeness or compactness of spheres or particles or spheres in closed packed structures. The closeness or compactness of particles or spheres in the crystal lattice is directly proportional to the coordination number. That is, closeness or compactness of crystal lattice increases with increasing coordination number and vice versa. These are some important points regarding packing of particles in the crystal lattice. First point, the constituent particles in the crystal lattice are closely packed. These particles are treated as hard spheres. Closeness or compactness of the constituent particles maximize the interparticle forces of attraction. The coordination number of any particle or sphere in the crystal lattice is nothing but the number of neighboring particles or spheres that touch the given particle in the crystal lattice. The magnitude of coordination number is measure of closeness or compactness of particles in the closely packed crystal structures. The closeness or compactness of spheres or particles is directly proportional to the coordination number of the particle or sphere. That means closeness or compactness of crystal lattice increases with increasing coordination number or decreases with decreasing coordination number. Now, packing of crystal lattice takes place in 3 stages. One by one. constituent particles in the crystal occurs in one dimension, then two dimensions, and finally in three dimensions. First, close packing of constituent particles or spheres in one dimension. That is 1D. In this stage, spheres are arranged in linear fashion. Particles or spheres are arranged in linear fashion, touching one another to form rows. Schematically, you can show linear arrangement of constituent particles. This is row. Particles are arranged in linear fashion. One particle is in the neighborhood of two particles and coordination number in 1D arrangement is 2. There are depressions in between two adjacent constituent particles in 1D arrangement. Then second stage, close packing. Close packing of constituent particles. Constituent particles or spheres in two dimensions. Or 2D arrangement. In this stage, two or more rows of constituent particles or spheres are arranged one over another, forming sheets. This arrangement takes place in takes place in two ways. In two-dimensional arrangement, two or more rows of constituent particles are arranged one over another, forming sheets. And this arrangement takes place in two ways. First, square close packing. Square close packing. It is also treated as A type arrangement. In this arrangement, rows are arranged one over another in such a way that particles of one row exactly reside on the particles of another row. This is square close packing 2D arrangement. Here, if you think of any particle in the crystal lattice, one particle is surrounded by four other particles. This is arrow, arrow, arrow and arrow. Each particle is surrounded by four other particles and therefore coordination number of this arrangement or coordination number of any particle in this square close packed arrangement is 4. Then second arrangement, this is square close packed sheet. It is treated as A. Second arrangement, hexagonal close packing, or it is also called as AB type arrangement. In this arrangement, rows are arranged in such a way that particles of one row fixes in the depression of other rows. This is ADV type arrangement. Here in square close packed arrangement, square is formed or square of wide is formed. But here, when rows are arranged one over another in such a way that particles of one row mixes in the depression of other row, such sheet is formed. It is called AB type hexagonal close packed AB layer or sheet. Here, if you think of any particle in the sheet, it is surrounded by 6 other particles, and coordination number of any particle in the AB type arrangement is 6, and your hexagonal void is formed in the AB type sheet. Here A, B layers are arranged one or another in alternate fashion in such a way that particles of B layer fixes in the depressions of A row and such sheet is formed. Here in AB type sheet, it is important that alternate triangular spaces are formed, and these spaces are triangular voids in opposite directions are formed in AB type 2D arrangement. Now, third point or third arrangement we have to discuss about. It is close packing. Close packing of constituent particles or spheres in 3 dimensions. Or it is 3D arrangement. Here also packing takes place when 2 types of layers, 3-dimensional or 3D crystal structure is obtained by stacking of square close packed or they are also called A sheets. Or hexagonal close packed upon alignment of sheets one or another, or alignment of particles in the sheets on one another. Generally, stacking of square close packed AAA sheets forms close packed cubic or CCP crystal structure. In 3D arrangement. It can be shown like this. Particles are arranged exactly on one another, which align vertically and horizontally. Particles align on one another and such cubic close packed structure is obtained. Here, if you think of any cube such cube is formed when any adjacent four particles are taken from this structure. 4 particles of one layer and 4 particles of its adjacent layer forms cube. In this way, all the particles are arranged in cubic close packed manner. Here, coordination number of this layer or this structure is 6. That means these are 4 particles of one layer, 1 particle of upper layer and 1 particle of lower layer, and middle particle. Any middle particle, single particle is surrounded by 6 other particles, 4 particles in its layer, 1 particle above the layer, above, and 1 particle below the layer. In this way, coordination number of CCP structure is 6. In this way, stacking of AA layers in as usual manner takes place, forming closely packed cubic or CCP structure in 3 dimensions. Here, every particle aligned vertically and horizontally on one another to give CCP structure. And here, coordination number of CCP structure is 6. If you think of any particle in the CCP structure, it is surrounded by 6 other neighboring particles, 4 in its own layer, 1 particle above the layer, and 1 particle below the layer. Total 6 particles surrounds any particle in CCP structure, and therefore coordination number of CCP crystal structure is 6. Now, second type we have to discuss about stacking of hexagonal close packed hexagonal close packed ABAB sheets which forms hexagonal close packed or it is abbreviated as Scp structure. Here in stacking of A type sheets, CCP structure which is same as FCC structure. If question is asked what is coordination number of CCP or FCC structure, you can tell it as 6. In stacking of hexagonal or ABAB sheets, hexagonal close packed SCP structure, it is also same as FCC structure also. Now, how it is formed? Here, in stacking of hexagonal sheets on one another, it is important that triangular voids are formed. Voids are formed in each sheet. We have seen previously in each sheet. It is important that all the triangular voids are not covered by spheres of another sheet, another adjacent sheet. In AB arrangement. The triangular voids of one sheet, one ABAB sheet, which are covered by spheres of second space, spheres of second sheet. Or tetrahedral voids, tetrahedral voids. Each of which is having coordination number, or each of which is surrounded by four spheres, neighboring spheres. Now you can see how this arrangement takes place. Any three adjacent particles of one layer to take. Here magnified picture I can show. This is triangular void. And if on these three particles of one layer, one particle of other layer is arranged exactly in the triangular void, you can have such diagram. Here, by arranging one particle on the triangular space of particles of another layer, you will have tetrahedral void, and tetrahedron is formed. Tetrahedron is formed. Now, the remaining particles, remaining triangular voids, which are not covered. Remaining triangular voids are covered by triangular voids of second layer. Second layer of sheet are covered by remaining triangular voids are covered by triangular voids of wide. How this octahedral wide is formed? Suppose this is triangular wide of first layer, and if you arrange triangular wide of another layer, second layer on one another, that means triangular wide of first one layer having triangular wide of another layer on it, and it forms octahedral wide. It can be shown like this. This is octahedral wide. This is triangular wide of one layer, and triangular wide of another layer is shown by dotted lines. This is octahedral wide. In this way, two types of wides are arranged or formed in close packed three-dimensional structure, tetrahedral wides and octahedral wides. Now, in any crystal lattice, if you think of the arrangement of ABAB three-dimensional seed or crystal, here one thing is important, you can know about coordination number. Here in ABAB seed, each particle is surrounded by 6 other particles of one seed. Again, there are 3 particles of 2 layers, one above the layer and one below the layer. Here, coordination number of SCP structure is 12. How 6 particles in its layer, 3 particles above layer and 3 particles below the layer. Total 12 particles are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. In this way, coordination number of SCP structure. Here, it is also said like MCC structure. Examples of such type are metals like Mg, zinc. They have SCP structure, and example of cubic close packed structure is polonium. Cubic close packed structure is present in polonium. Now here, in example structure. This is one way of arranging AB layers on themselves. Here, AB layers are arranged as usual in such a way that particles of B layer fixes in the depressions of A layer. In this way, number of layers are arranged one over another, and coordination number of such structure is 12. It is explained here. Second way of arrangement is done for packing third layer C to cover octahedral lines. First way is done to cover triangular voids, remaining triangular voids by triangular voids of one layer. Second way is done for packing of third layer to cover octahedral voids of one layer. Here, these layers do not align one over another. Here, crystal structure. Here you can see coordination number, again it is 12. How? This is AB sheet having coordination number 6. When three layers A, B, C are arranged in alternate manner on one another, what happens? Three particles of one layer above the sheet and three particles below the sheet. Total number 12. 6 particles in the layer, 3 particles above the layer, and 3 particles below the layer. In this way, these particles are arranged and hexagonal close pack, and also here cubic close pack structure is formed by such arrangement CCP, which is same like FCC structure. Its coordination number is also 12 in second way of 3D arrangement. Examples: copper, silver. These metals have CCP layer or arrangement. The same arrangement can be shown like this. Three layers above, 3 particles below the layer. In this way, it undergoes propagation to form CCP layer. If these 4 layers are touching one another, a cube is formed. Cubic close packed structure is formed whose coordination number is 12. In this way, in AB arrangement, 3D arrangement of sheets, A sheets and AB sheets takes place in two ways. One way in which AAA sheets are arranged as usual to form cubic close packed crystal lattice. In second way, one layer is arranged on one another in order to cover remaining unoccupied triangular spaces or voids of one layer by octahedral voids, and coordination numbers of both cases are 12. In this way, we have seen how packing of unit cells or constituent particles takes place in three stages: 1D, 2D and 3D stages forming crystal lattice. Thank you.